Hi, welcome to the Rhetorical Data Visualization course. The goal for this first lecture is to give you a sense of what is rhetorical data visualization and what will be covered in the course. So welcome. I hope you're going to have a good time following these lectures. So what is rhetorical data visualization? I think that in order to answer this question, we first have to start with the question, what is data visualization? So I'm assuming that if you're interested in this course, you probably are already somewhat familiar with data visualization, but it's useful to briefly explain what it is about, right? So data visualization is about the science and the practice of taking data and transforming it into a graphical depiction so that you can better understand the information that is contained in the data. And this is typically used for two main purposes. One, for analyzing the data and understanding the information that is in there. And second, very important, to communicate the results to others. So mainly for analysis purposes and for communication purposes. So anything that is a plot, a graph, a network, even some sort of diagrams is data visualization. Now, what is rhetorical data visualization? Well, let's start with defining rhetoric, right? So rhetoric is the art of persuasion. I took this from Wikipedia. And they say rhetoric aims to study the techniques writers or speakers use to inform, persuade, or motivate their audiences. So because of that, rhetorical data visualization basically means how do we study data visualization as a tool to persuade other people. So more precisely, I came up with a couple of definitions. The first one is the use of data visualization to build persuasive arguments. But sometimes I think people react somewhat badly to the term persuasion and persuasive, and for good reasons. So another definition that I like that doesn't include the term persuasion is the use of data visualization in support of an argument, right? So you can imagine you have an argument. This argument is supported by data. Really important. We want to be, often we want to provide support for our arguments through data. That's one of the most powerful things about data, right? We like to talk about facts coming from data. And the idea here is that rhetorical data visualization is the use of data visualization in support of an argument. And this happens all the time. It happens in journalism, in business, in marketing, in politics a lot, in science, pretty much everywhere. So it's very important. So to give you a better sense of the problem here, I collected a couple of examples. So let's assume that you have an argument regarding games and the fact that despite the fact that some people may think that playing games can lead kids to being more violent, right? You actually believe that this is not true, and you look around and you find some data, and you want to present the data, the evidence that supports your argument that in fact video games do not lead to violent crimes. So you find this interesting graph that shows that the violent crime offenses actually decreased over time. And at the same time, the number of video game sales increased over time. So there's this kind of like opposite trend. And hopefully this is a persuasive argument in favor of the idea that video games do not actually lead to more violence. But maybe there's another person that comes and say, no, look, I actually think that you are wrong. I have some other evidence, and that's my evidence. There's data collected about how many hours that correlates basically how many hours children play video games. This is what you see on the x-axis, and on the y-axis is the percent who reported cyberbullying others, right? So the more hours played, the more hours of video games played, the higher the reported percent who reported cyberbullying others. So that's in support of the opposite argument, which is no, look, there's evidence that playing a lot of video games, especially playing games a lot, may lead to more violence or more bad behavior somehow. So that's interesting. We have two different data sets, two different plots, and they support completely different arguments. So this is an interesting problem, right? You can imagine many other situations where the same thing happens. In fact, this happens all the time. There's a person that argues in favor of something using data, and a person that argues against something using some data, and often even the same data framed in a different way. But you may ask, wait a minute, I've heard that data speak for itself. So what's going on here? I thought that it was just enough to show some data and then convince people. And here we go. What's in the data is the truth somehow. But unfortunately, it's not that easy. That's not really the way it works. So there is always a frame. So the idea of framing is really important, right? Every time we are communicating data, well, there are a lot of things that we are doing in the background that constitute a frame. And that will be a constant element of this course, right? And defining what a frame is gonna come little by little. But basically, you will see that everything is framed somehow, right? You can't really escape this necessity. It's inescapable. So let me give you a few elements here. So for instance, what question you ask precisely is a frame. So you may use the same data set, but ask a slightly different question or investigate a slightly different question. And now your question becomes a little, a different frame, right? You may use a different data set. So for instance, the example that I've just shown uses two completely different data sets. And in fact, you can argue completely different things or provide evidence for completely different opposite arguments. But you can also choose to select different elements of the data or filter different elements of the data or transform the data in different ways. And this can constitute a frame. And ultimately, you can decide to visualize the data in a different way. And once again, that's a choice that you have to make. You can use different titles and annotations and so on. So I hope that I gave you a sense of the fact there are many choices you have to make when you create data visualization. And these choices are inescapable. It's not like you cannot make these choices. You will have to ask some specific questions. You will have to use some specific data sets. You will have to use some selection, some filtering, some transformation. You will have to choose what graphs or visual representations to use, what titles and annotations, and so on. So every time you do these things, you decide to use a specific frame. So it's inescapable. So let me give you an example here, actually a few examples that I think are going to convince you even more that we have a specific problem here that is really interesting and actually has some complexity in it, is sophisticated somehow. So I'm going to show you a few examples where we have the same data and different framing, and because of that, we might get to different interpretations. So the first one is an example that I took from Twitter a few weeks ago that I really, really like, because here you have exactly the same data, but also exactly the same graph. The only thing that changes is some colors and the titles that you see on here on the left. And I like it because this makes it clear what we mean by framing, right? So here we have the first one, stating, enjoying one's own company. As Americans age, they spend an increasing amount of time with themselves. So on the x-axis, you have the age, and on the y-axis is the amount of time they spend either with themselves or with their partners or with their parents or other people, right? And from the graph, you see that the amount of time they spend with themselves is increasing over time, right? So this is like a positive spin, right? Oh, look, people are really enjoying themselves. So the next one, exactly the same graph, but the colors are different, right? It doesn't put an emphasis on this specific line that goes up, and it's more neutral. Um, who Americans spend time with the most by age? Very neutral. It doesn't judge. It doesn't provide any judgment, right? And the last one is exactly the opposite. Once again, this line is highlighted, and there's a big text here. All alone, as Americans age, time spent alone drastically increases. Isn't that interesting? Same data, same graph, slightly different coloring. Well, not slightly different coloring and different titles, and it puts you in a completely different frame of mind. So, really interesting. Second example comes from Alberto Cairo's book called How Charts Lie. And it's a really interesting set of maps coming from depicting information about the 2016 presidential elections. And here you see a map that you probably very similar to many other maps you have seen before about elections. So what do you have here? You basically have the share of vote in every single county, right? And when you look at this map, what do you see? Oh, you see a lot of red, right? A lot of red means that where there are a lot of counties where the share of the vote went mostly Republican. So when you look at this, it looks like landslide victory from the Republican Party, right? Okay, but let's see the same data in a different way. So this is the next one is a second way of visualizing this information. Instead of visualizing the share of, sorry, let me go back. Instead of visualizing the share of votes, here you can, what is visualized is the number of votes, right? So of course, where there's more people, there are more number of votes. So now here on the top left, you can see that the situation is different because there are areas with a lot of people, so a much higher number of votes. So it seems way more balanced now, right? And if you look at these two maps on the bottom right, now you have the votes for Trump, the votes for Clinton, and it looks even more balanced, except that you can identify areas where the two candidates were more popular, right? Now, but what is interesting is that the elections are not won through the popular vote, and they're not won through the share of votes that we similar to the maps that the first map that we saw. The elections are won actually according to electoral colleges and electoral votes. So here is a different map that actually shows the electoral votes and how they contribute to the elections. And this is much more, much closer visualization to what actually happens. And you can also see how close the two parties and the two candidates were at the elections, and also where they actually won. So this is really interesting, right? Once again, completely different visualizations bring a completely different message. Even though the reality the data comes from is always the same. It's not like the reality has changed in any meaningful way. Next example, this also comes from Alberto Cairo from his blog, I believe. And this is a redesign of a chart that has been produced by, what was that? I think South Carolina. I don't remember exactly. And an healthcare division in South Carolina. And what you see here is the original bar chart that has been created. And the intent of this chart was to show the top 5 counties with the greatest number of confirmed COVID-19 cases over the past 15 days. And if you look at this chart, the first impression that you get is that basically there is a decrease over time of the cases, right? But the problem here is that if you look carefully, these dates here are not in order. In fact, that was not even the goal of this chart. The goal of this chart was to show that for different periods of time, there were some counties that there were always first or second or third, right? So the idea is to look at these groups of bars. But then Alberto Cairo rearranged these bar charts in a different way. So it's exactly the same bars, exactly the same data, but rearranged in a different way. And now you have a completely different message, right? So this is really interesting. Same data, same type of plot. The only thing that changes here is how the bars are arranged in the visualization. And here we go, completely different message. Isn't that amazing, right? Another way to think about framing. You change the way the bars are arranged, and now you get a complete type of message. Next one, I took this one from a presentation from my colleague Michael Correll, and a really interesting one. So this is the average global temperature by year, starting from the 1900s up to today or a recent time. And the only difference between these two is that here you have the same graph where the axis has been truncated, right? So the temperature starts from around 55.5 Fahrenheit, whereas here it starts from zero, right? When you do that, you have a very flat line that basically conveys the idea that, well, the average global temperature didn't change much. But when you visualize it that way, it's exactly the opposite. It's, wow, it changed a lot. So again, isn't that interesting? It's exactly the same data. It's exactly the same type of plot. The only difference is a little tweak, and it's a completely different message. In fact, it's the opposite message, right? Very powerful. Last one I want to show is interesting set of maps coming from Lisa from Data Wrapper. She, by the way, she creates really beautiful tutorials, including many on color. And this comes from one of the many tutorials that she created on color. And what do we have here? So we have US map showing unemployment rate. If you look at the legend on the bottom right, you see the colors that correspond to 5%, 10%, 15%, 20%, and so on. And you'll see that there's a very high concentration in the map. Let me see if I can use the pointer. So here there's a very high concentration of unemployment, but the rest of the map is pretty much washed out. You can see a lot of differences. Yeah, maybe you can see a few higher areas here and a few higher areas. Oops, sorry, I went too far. A few higher areas here, but not much, right? So what she shows is that there are different ways to map the values to the colors. And if you use different mapping strategies, now you see completely different patterns, right? So look at this one, for instance. This is different ways of mapping through quartiles, which is basically a non-uniform mapping between the values and the colors. And now you see a completely different structure, right? You see that it's way clearer that there's very low values here in the middle and high values in this area and high values in this area around here, right? So very powerful. Once again, so here is different. We have the same data. We have the same type of plot, choropleth map, but the difference between these maps, it's no longer say how an axis is scaled, but it's more about how we decide to map um, the quantities to the colors. And once again, you can imagine people coming up with different impressions or different interpretations of this data if you use different color maps. So I went through quite a few examples, and you might ask how many different ways to frame a visualization, because we have seen quite a few. Well, let's try to summarize what we have seen so far. So we have seen different framing coming from using different titles and different highlighting preferences, right? Then we have seen framing coming from different metrics and calculations in the electoral maps, right? In some maps, we showed shares of votes. In the other one, the popular votes. And the other one, what was it? The electoral votes, right? And so different metrics, different calculations provide different messages. Then we saw different arrangements. And then we saw different ranges and scaling. And then we saw different visual mappings, strategies. So these are many different ways. And the outcome is the fact that you may extract completely different messages from the same information. And my goal here is to show you that the same data can be framed in very different ways. And my second goal is to show you that there are many different ways to do that kind of framing. So these are just examples. There are other ways to actually have different framings, right? So another thing that I want to highlight here is that while some of the choices made in the visualization that I've just shown may be questionable or more questionable than others, these are actually all legitimate visual representations. It's not like these visualizations are wrong in any meaningful way, or they contain some blatant lies or falsification, right? There's no specific manipulation or falsification, right? As a side note, you can imagine someone coming up with completely fabricated data, right? None of these examples include fabrication, right? So these are legitimate visual representations of the same data, sometimes different metrics. And again, they may lead to completely different interpretations, which I think is a really interesting problem. So now you may look at this and think, wait a minute. I thought that data was objective, data was the truth, data is evidence. You just show me that this is maybe not true. Well, does it mean that it's all subjective then, right? Because you may very well think that now it's exactly the opposite. Data is not really important. Evidence is not really important. You can always steer people to the direction that you would like them to go. So yeah, it's all subjective. Well, no, it's not all subjective. Some data facts and some visualizations are more truthful than others. And part of the challenge of this course is actually to dispel and look at all the ways in which specific choices may be leading to more truthful visualizations and better evidence for an argument that you want to put forward. I actually believe that there's a spectrum, right? You can go from lies and frauds, which is what I was mentioning before, like fabricated data that would be pure lies, pure frauds. You can then go to slanted visualization, so that it's not really a lie, but there's a really strong bias or slant in the titles, in the way that the visualization has been arranged, in truncating some axes here and there, many other possibilities here. Then there's some partially biased evidence, so mostly legitimate, slight bias. And then you can have high quality, rich, and nuanced arguments. And often I think that when you find high quality, rich, and nuanced arguments, typically, not always, you achieve that by introducing multiple perspective and by looking at the same problem from different angles. And I have to say that this is what happens in good science normally. When you have good science and scientists coming from different angles, sometimes you have a group of scientists arguing for one thing, the others argue for another thing, and they tend to be respectful. They try to provide evidence, and they are coming from multiple perspectives. So this is maybe our gold standard. One thing that I like to show here is that, for instance, in medicine, there's something called hierarchy of evidence, right? This is not the only way to look at evidence, is one example that I found, right? And you can go from, right, something that is just expert opinion, background information, and it gets better and better in terms of quality. You have case reports, case control studies. So this is basically about a few people, observational. Then you have cohort studies, and then you have one of the gold standards that is randomized controlled trials. And then you have summaries of multiple randomized controlled trials, which is basically what you have in meta-analysis and systematic reviews. So well supported and high quality. So this definitely exists in some areas of science. And I'm only talking about this without giving too many details to give a sense that no, it's not true that it's all subjective. It's actually possible to provide better evidence and better depiction of that evidence. So realizing that everything is framed somehow shouldn't lead us to think that any visualization is equivalent to another, any piece of evidence is equally good to any other piece of evidence. There's actually a hierarchy right there. So now I want to conclude with trying to convince you that studying rhetorical data visualization is really important and exciting. So why study rhetorical data visualization? Well, we established that data visualizations take place in frames of reference. So I believe that it's really important to become mindful of how data are framed, which is partially what I have already introduced in this lecture. Then you want to be able to recognize and assess the validity of an argument communicated through data visualization. So how good are you at recognizing potential problems, or actually recognizing that a piece of evidence or multiple pieces of evidence communicated through a data visualization are actually pretty solid? Third, developing DataVis frames with integrity. So not only assessing, but also being able to produce yourself data visualizations that are actually really strong, really good, and how to produce them with a high level of integrity. And finally, one last thing that I want to highlight, also learning how to disagree constructively when frames or arguments differ between people. And I think that's a really, really important skill as well, right? What if you want to produce a given argument and there's another group of people or a specific person that produces a completely different argument, still using some data and some data visualization? How do we have a dialogue, right? Because if we don't know how to have a dialogue, we might just end up fighting, which is not particularly useful. So how do we disagree constructively, and especially how do we learn from each other? I think that's also a really important point that may fall into the scope of this course, and I'm hoping to cover later on in the course. Just a little note here. I think it's really important to be humble. We're going to explore some really difficult and tricky questions in this course. And the goal of this course is to generate an awareness of the complexity of some problems. And even myself building this course, I don't have answers for everything. And in some cases, I will produce more questions than answers, actually. And we might actually go a little bit philosophical at times. This may be a little frustrating, but I think it's important to develop some sort of humbleness for how complex this topic is. And in fact, as I said, one of the goals of this course is actually to clarify and make it explicit how hard it is to reason about these problems. So now I want to finish with what I call the rhetorical visualization framework. Let me make some space here. Okay, so when we talk about visualization, I find it important to give a framework that describes the steps of what is going on here. Well, what is going on? First, we have some real world phenomena, right? We look at data because we want to analyze, we want to understand some real world phenomena, right? So it's not like we are particularly interested in data because we like data. Well, maybe some of us might actually like data, but we look at data because we want to understand real world phenomena. So somebody somewhere somehow collects some data that describe this phenomena, right? It may be ourselves, it may be more often some data that has been collected somewhere else. Then we may do some selection within this data, for instance, selecting what variables we want to inspect. We will do some transformations. And then we might come up with some specific measures and some statistics we are interested in. And then we create visual representations out of them. And then we build a narrative around them, providing some context, some text. This may live in a presentation. They may live in a specific document. And so there's typically some sort of delivery mechanism. There will be a sequence, there will be titles. So again, as I was saying at the beginning, all choices that we have to make there. And then there will be individuals, people that we are communicating to. So understanding who these individuals are, and especially what is their background and maybe even their attitude can help us make choices there. And finally, there will be groups of people that discuss and communicate this information to others, right? And so there's the societal level of the impact that your visualizations have, not only to specific individuals, but also to groups of people or to society at large, right? Imagine even within an organization, if you work in an organization, you want to be able to reason about not only the individuals you are communicating to, but also the groups of people that are within your organization. So for each of these topics, for each of these elements in the framework, we will be covering some specific topics in the course. So there is an association between the elements of the framework and the topics that I am planning to cover. So for collected data, I'm going to talk about data reality gaps. So gaps that may exist between what you would like to know and what is actually in the data. Then for selection and transformation of the data, you will have what I call data-driven framing and focus, right? The idea here is that according to what you decide to focus on in the data, you will have some framing. Then looking at measures and statistics, we will cover how do you make inferences out of specific measures and statistics, and how you may actually find some specific fallacies, right? You may infer something out of a statistic or out of a visualized statistics in our case, and infer something that is completely wrong. Okay, so how can people, or how can we ourselves get fooled by these visualized statistics, and how do we prevent ourselves to being deceived by these statistics and these visualizations? Then we have visual representations. So we will look into graphical variations like the one that we saw in some of the examples. And we will also cover specific visualization techniques that are known to be misleading. Then covering the narrative context, the narrative, the context, and the delivery, we will talk about narrative techniques in data visualization. Then focusing on individuals, we will cover specific aspects of what I like to call visualization psychology. So what do we know about cognitive psychology that can help us better understand how individuals may absorb the information that we produce through data visualizations, and also where and how they may come up with different interpretations, right? Different people may interpret people differently. So how do we reason about this problem? And finally, at the group and societal level, we would definitely want to cover ethical concerns. We want to cover integrity. And similarly to what I was saying before, how do we enable what I call data-driven dialogues? So how do we create really good dialogues around data, and hopefully communicate with people that have a different argument from us, and to do it in a respectful manner. And even better, how do we do it in a way that at the end of our conversation somehow all parties become more informed, right? That would be the best goal for a data-driven dialogue. So this concludes this introduction. I just want to briefly mention some works or some papers that inspire this course. The first one is a great paper that is called Visualization Rhetoric, Framing Effects in Narrative Visualization. This is basically the main inspiration for this course, as you can imagine looking at the title. And in this paper, the authors introduce the idea of visualization rhetoric. So I look at this as a landmark paper in visualization research. The next two papers come from my own research and my own group. A few years back, I've been studying deception with visualization, and actually running experiments showing that people do get deceived by visualizations. And so there's a real problem there. So when you actually look scientifically at what kind of information or impression people get out of certain plots, especially plots that are designed to be somewhat deceiving or misleading. I like misleading better as a term, even if originally we used the term deceptive. So big problem there. And the next one is research that we have done on persuasion, showing that graphical depictions of data, in our case, compared to tabular depictions of data, can actually, in certain cases, lead people to be more persuaded by what they are shown. So the idea here is, if I show you a graph, is it more likely that you will be persuaded by my argument, right? And yes, it turns out that under certain conditions, especially when people don't really have a very strong attitude towards the um, specific topic that you're covering with your visualization and with your data, they may be more strongly persuaded when they see a graph rather than a table. And as you can imagine, all of these things inspired the ideas behind this course. So I'm really hoping to be able to inform everybody about all these elements that I just mentioned and that we are going to cover in the next set of lectures. So this concludes the introduction. And if you want to make sure to get information about future lectures that I'm going to publish, you can do that by signing up to my newsletter. I have a newsletter in Substack, FILWD, which stands for Fan in Love with Data.substack.com. You can also follow me on Twitter X, where my handle is the same acronym, FILWD. And you can also find me on LinkedIn if you prefer, just by looking at my name. I am just E. Bertini, or I guess if you look for Enrico Bertini on LinkedIn, you are going to find me there. So I hope you enjoyed this introduction. I will be preparing new lectures and I will be posting them as soon as they are ready. And in the meantime, if you have any question or comment about this specific lecture, feel free to reach out to me in any of these channels. See you next time.